Okay, so today I'll introduce to you only intro to organic chem. Okay, the basics, right? The actual thing next week or so. So you need to know that petroleum is actually crude oil. I say again, the word petroleum on top is actually crude oil. It's the same. You understand? Right? If you see this picture, right? The machine or the what's it called? Right, they go under the seabed or under the ground to take away or to take out the crude oil. Understand? So crude oil and petroleum, they refer to the same thing, and it's very precious and it's non-renewable. Remember that? I think this one you should know, right? Non-renewable. Because one fine day it will be used up. Okay, and why is this petroleum? Why do we need to study, and why a lot of companies do this and earn a lot of money? Is because, can you see, it's so useful, right? So after you undergo this thing called fractional distillation, right? Because it's okay. So first of all, you need to know that petroleum or crude oil, they are mixture, right? Because it is a mixture, therefore I can undergo a physical method of separation called fractional distillation based on different boiling point. Okay, right? So the petroleum, they dig underground. My impression, I think it should be a black liquid, right? Very precious. So sometimes they call it black gold. It's very precious, right? When they do fractional distillation, the first fraction or the first thing that come out is petroleum gas. Okay, with the lowest boiling point. So you can see that this thing is being arranged according to ascending boiling point from small to big, right? Right. So petroleum gas is and all these you must know, they are what? Simple molecular structure, right? Simple molecular structure for all this. Therefore, if you can remember early part of Sec 3, right, you learn about chemical bonding, or even in the periodic table group 7 halogens, right? Last week, I think I taught you group 7. You must know that this is the smallest molecule, and this is the largest molecule. You understand? Petroleum gas is the smallest molecule, and bitumen is the largest molecule. Okay, wait, before I answer why. Since it's the smallest molecule, the what thing? Intermolecular forces of attraction between molecules weaker. Understand? Okay, since you ask why about what? Why is it smaller? No, like it's just small molecule or less carbon atoms. This one, a lot of carbon atoms. Is that why? Which part is why? So you understand, So why you got a lower boiling point? Because the intermolecular force of attraction is weaker. Why intermolecular force of attraction is weaker? Because it's a smaller molecule, you understand? Remember now, this is about simple molecular structure. The smaller it is, the weaker the intermolecular force, like fluorine versus iodine. You understand? Okay, understand? So petroleum gas come out first, followed by petrol or gasoline, right? So this is petrol and gasoline is actually in the along the road. There's a Shell station, SPC station, Caltech station, right? You pump the petrol into the car. That's called petrol or gasoline. And I say first, petroleum, different thing. Petrol is part of petroleum. You understand? Okay. So I forgot to tell you, petroleum gas is used for cooking. I need to memorize for 1 mark or MCQ. So petroleum gas is used for cooking, right? Petroleum gas, you can write down mainly methane. Okay, so petroleum gas is made up of mainly methane and it's used for cooking. Is the person carry the blue color cylinder to your house? For some houses, it's electric nowadays, but some houses, the stove, there is a petroleum gas, mainly methane. You understand? For the stove, for the fire. Petrol for cars, naphtha is a feedstock for petrochemical industry. Feedstock is actually your raw material only, right? You can write raw material, okay? Petrochemical industry, basically animal chemicals or some materials. I still don't know what. Okay, paraffin or kerosene is for aircraft, right? Fuel for aircraft. Diesel is for diesel engines like the trucks and some taxis. And nowadays some taxis also become electric, like hybrid or what. Lubricating oil is for lubricants and wax, and bitumen is for making road, right? Or surfacing road, similar, not similar. Surface road, we can also use molten slag. So we need to memorize this sequence because they might give you an unknown, fill in the blanks or what, understand? Or they ask you about the use, or they ask you about the sequence. Do you understand? So how to memorize this sequence? Of course, some teachers will come up with a story. If not, come up with a story. If not, use mine, right? Right? Peter Pan never play drums like boys, right? The first alphabet of everything. Peter, petroleum gas. Pan, petrol. Never, naphtha. Play, paraffin. Drums, diesel. Lubricating oil, like boys, bitumen. Understand? Can you explain the part of the weaker the molecule is small? Yes. Remember last week I said the smaller the molecule, remember not? F2 versus I2, right? So the smaller the molecule, the weaker the intermolecular forces of attraction between molecules, right? Remember not? For group 7. But for metal, the smaller, the stronger. But this is simple molecular structure. Do you understand? So fluorine is a gas, but iodine is a solid because iodine is a larger molecule. You understand? The larger the molecule, the stronger the intermolecular force. Do you understand? Remember I draw a picture last week? Periodic table, is it? Right here. Okay. Smaller molecule, weaker intermolecular force. Larger molecule, intermolecular force very strong because they like overlapping each other very well. Like they're so far away. No. Hey, cannot talk about gain electron. Gain electron or lose electron is reactivity. Yeah, I say first. Remember, I told you it's a separate thing totally. Reactivity and melting boiling point is a physical process. It's a different thing. Cannot think of that. It's an independent. I know last week you also tried to link. Cannot. It got to be in a different section of your brain. It's a totally different concept. Understand? Gain or lose electron is reactivity. Put one side of your brain. Intermolecular force is melting boiling point. Another side, different thing. Just learn it independently. I said, don't link them together. Link them together, which a lot of students will link them problem. I said, okay. Hey, so can you take 1 minute? I give you 1. Okay, so lower boiling point should be produced first. Fractional distillation, remember classic example in the notes is what? Ethanol and water. Ethanol will come out first, lower boiling point. Right? So the lower boiling point will come out on top, and first is a petroleum gas, accordingly, following this sequence. It's a mixture. That's all. Again. Okay, now. Okay, this part, of course, I have to teach slowly because, okay, Aaron, maybe you know already, but the rest of you, maybe if you haven't touched this before, this might feel a bit weird, but it's not difficult. Don't have the impression. A lot of students have the phobia what organic is going to be tough, or my seniors say tough, or my teachers scare me. No, it's not tough. I feel it's even easier than electrolysis. I feel lah. But electrolysis also, if you master and do a lot, it's also not tough. So everything is about practicing. Okay, now before I look at the orange one on top, wait first lah. So what happens is that now we are in your O-level syllabus, we are going to learn, okay, 4 chapters, means 4 different families of, or to be more precise, 4 different homologous series. Means it's a family of organic compound, all same one, same kind of pattern. Like later we see, like for example, same general formula, functional group. Okay, of course you don't know what is it. If you never learned this, we thought. So basically, I just want you to know that same. For example, like all the mammal, certain things same, right? Reptiles, you understand what I say? So now, we are supposed to learn all these four. Normally, I don't have to teach this because it's very weird. Because I'm supposed to teach you alkane, the whole chapter, like alkane, and then okay, but never mind. Now, for the sake of Aaron's exam and okay, since I don't have so Aaron's exam. Okay, so alkane got no functional group. Alkene, the functional group is CC. There you say, what is functional group? Okay, functional group means the characteristic or the property that you look at the compound, you know, oh, it's an alkene. So if the compound got OH, oh, it's an alcohol. If it's a COH, oh, it's a carboxylic acid. If you see this, oh, it's an ester. So if you learn this first time, you feel a bit weird, but don't worry so much. Means what? I draw this. Okay, carbon form 4 bonds, right? In the periodic table, carbon form 4 bonds. Okay, so for example, this. Okay, so as long as you follow carbon form 4 bonds, means got 4 lines around carbon. Is correct. So this is an alkane. This is an alkane. But if I draw like that, carbon form 4 bonds. Okay, this is an alkene. Because of these, there is a double bond, right? Can you see a carbon double bond? You understand? For those who learn first time. So functional group is like why alkene is alkane, is it? I mean alkane. First one, alkane, is it? So alkane do not have any functional group. Some notes wrong. Hey, alkanes do not have any functional group. Some notes or some teacher, they're very funny. They say alkane contain carbon-carbon single bond. That, I mean, it's true, but it's not a functional group. Do you understand? So basically, the first one, because can you see all single bond? See, all single bond. That's an alkane. But if there's a double bond somewhere, it's an alkene straight away. You understand? So alkanes do not have any functional group, but that should be the actual thing. Understand? So alkane, in other words, I mean, okay, you ask me like that, how you know what's alkane? Those don't have double bond OH, and you understand? Like nothing wrong. That means the C, can you see how the blue one connected there is an alkane? No? You understand? That means I can draw like that. Alkane, no? Can you see not? There is no double bond, right? You understand? Sort of, but don't worry so much when you do the question. Have you learned this in school? Okay, so don't worry. Okay, sort of eliminate, but after that, very easy one. Trust me. You got to trust me on this. By the way, today's lesson, I mean, benefit more to Aaron and me, okay? Because I'm not going to practice this. After this, you got to rush through to a test. So like a little class practice. Okay? So don't worry, but I'm supposed to teach you what a functional group means. Like for example, the functional group, I mean just random lah. Like, I mean not always, but what I'm trying to say, what is a functional group? Is like the functional group of a girl is like long hair, you understand what I'm trying to say? Even though some girls short hair, you understand what I'm trying to say? So functional group is that you see, you know what is it. Okay? So if they are from the same homologous series, they should have the same functional group. Which is why I told you what is a functional group. Okay, they should have the same general formula, which I teach you now, but a bit lame also. General formula means like that. Can you see? For alkane, what's the general formula? CnH2n plus 2. Can you see it? Means I sub in, like for example, I sub in C5H will be 12. So general formula means it's a formula that is sub in like E-math, you learn some, what is it called? Like last time as a kid, I like to do that, a very powerful one, very challenging but very fun. You get it, the general term, is it something like that? You know what's general formula? General formula means you sub in the N. N means the number of carbon atoms. That will be the formula. But alkene general formula is what? Different, right? You see? So alkane is what? CnH2n plus 2, alkene is CnH2n. But if they are all alkene, they will have the same general formula, you understand? But not going to teach you this today. But you understand? Okay, Aaron must know more for the test. But I know I don't like test only testing you intro one, very funny one, because it's like not here, not there. Okay. Next, successive members differ by a CH2 group. You see, I teach you like that, I also feel uncomfortable. You see, what the hell am I talking about? Correct. So you see, what is going on is like that. Successive members. So if it's a C4H, how many? 10, right? C3H8. Okay. Successive means one after another lah. So look here. Here to here, can you see I add in one C2H? Here to here, one C2H. Make sense? This for what? Alkanes, right? If it's alkenes, the general formula is CnH2n, right? This is CnH2n plus 2. So anyhow, let's say C20H40, C21H for the 2n. Okay, my mind cannot work. Correct. sorry. The lunch cannot work. C22H44. Can you see that even though it's a different homologous series, I also have a CH2 difference? So if they are from the same homologous series, successive member add 1C and 2H. That's a property also. Do you understand or not? Especially Aaron, must understand for a test. Aaron, do you understand? Good. Is there any question or what's going on? Are you lost? Okay, good. Jolie, have you learned organic? Are you there? Jolie, they taught you organic? Okay, don't worry. Today is just nice for Aaron. I don't know that Aaron this is tested, but anyway, just nice. My plan is today, and after you do the test, help you improve. Okay. Okay lah. So done. Okay. I think the first two is weird only if you never learn. The rest normal. If they are from the same homologous series, they have the similar chemical properties. Means you know what? They have the same chemical reaction. Means all alkane undergo a certain kind of chemical reaction. Alkene all undergo different, cannot mix one. You understand? Like all reptile something only, all mammal something, all birds fish. You understand what I say? Okay, and the last one, physical properties change gradually. So normally in a homologous series, the melting point, boiling point increase because they are all simple molecular. The molecule gets larger, stronger intermolecular force. Need to have this. I know this part very weird. I know Cynthia might feel weird just now. What intermolecular force, big Y like that? But this is big thing, and you need to know this until your A level. You understand what I say? The larger the molecule, the stronger the intermolecular force. For covalent, simple covalent or simple molecular. Okay, something like that. Okay, just the name. OH is called hydroxyl, COH carboxyl ester linkage. Never mind, this one no meaning one. Okay, no meaning for now. But when I teach you, everything got meaning. I said, don't worry so much. Just have the impression today a bit. Right? What I tell you, you know 30% enough of you. Very good. And when I teach you the actual topic, wow, everything will come. It makes sense. Do you understand? Any question until here? Look through for a while. Okay, let me pause the recording for a while. So this box is very important for simple molecular structures only. When the MR is larger, means you count 100 over, means the molecule is larger. When the molecule is larger, means stronger intermolecular force. Actually, got the last arrow means higher melting point, boiling point, because you need more energy to overcome. Ming Pai Ma, any questions? Okay, copy this box. It will help you for organic as well as halogen. Okay, 5 seconds. Okay. Now, this is the next part. Of course, hopefully, Aaron, you feel comfortable, but the rest of you might feel weird again, right? It's like a new language, so don't worry. After a while, it's like the first time you learn a third language, you find funny, right? After that, it's okay, right? It's the same thing. Don't worry so much. Now, so now this thing is very important. The prefix, super important. You know why? Because this thing will apply to the entire organic chem. So please learn properly, chem. Entire organic chem, including A level or IB, right? It's the same thing. Organic compound never change one. Understand? So what's going on is that if the molecule has one carbon atom, right? It's called meth. Means what? If it's an alkane, it's called methane. If it's an alkane, it's called methane. Finally, means methane will make sense. Last time we memorized it. 2 ethane, 3 propane, 4 butane, 5 pentane, hexane, heptane, octane, nonane, decane. You understand? Just a name means what? Methane. How many carbon atom? 1, right? 1. One carbon atom form 4 bonds. Ethane, how many carbon atom? 2. One carbon atom form 4 bonds. Is it not? Propane, 3, 4, accordingly. And why you need to learn this well, you know why? Because if it's an alcohol, it's called methanol, ethanol, propanol, butanol, right? Pentanol, follow. If it's an alkene, butene, pentene, hexene, heptene. So it applies to everything. If it's carboxylic acid, propanoic acid, butanoic acid, pentanoic acid. Oh, carbon need to form 4 bonds because it's group 4. This is chemical bonding. Right? Carbon need to share 4 with the 8, right? Carbon is group 4, check periodic table, group 4. You understand? Right? The dot cross diagram, carbon need to share 4, right? Means dot, cross, dot, cross, dot, cross, dot, cross. The carbon happy, the hydrogen happy. Hey, since you understand? So going forward, carbon need to form 4 bonds. Where is it? Alkane, alkene, alcohol, carbon says ester. It's still carbon. We don't care about the homogeneity. Carbon need to form 4 bonds. Therefore, alkene you might find weird because I can draw alkene like that. Okay, let's say that. So carbon need to form 4 bonds. Do you understand? Can you see the lines there, all the hydrogen? Ayo, no space. You understand? Can you see now? So, but when there's a double bond, then I just draw like that. Do you understand what I say? But I say, don't worry, when I teach you alkene, I'll ask you practice draw a lot. For now, you need to know carbon form 4 bonds. But the intro exam, I don't think that, maybe they will, alkenes like that. Good. So you must know the prefix well. So students say how to learn the prefix, not difficult. Remember last time, I don't know is it in syllabus now, but last time when I was a student, I know it's in syllabus. Remember the polygon? Remember polygon, the math polygon, number of sides different? I mean, different, right? So remember not? Pentagon, hexagon, heptagon, octagon, nonagon, decagon. You can remember? So only the first 4 doesn't follow math. 5 carbon onwards follow math. You understand what I'm saying? So pentagon, hexagon, heptagon, octagon. Okay, some school or textbook only stop octagon, but I want to teach you 9 and 10. Nonagon and decagon. 10 years is a decade, right? So the first 4, can you write down? Is just monkey eat peanut butter to memorize methane, ethane, propane, butane. You understand what I'm saying? You understand what I'm saying? So can you just write down to help you, or you got own story? Fair enough. Monkey eat peanut butter. Or you come out your own story. Your job is to learn it only. You understand? So methane, ethane, propane, butane is weird or is new. The rest follow math. Any questions? Okay, so this is the equation given there, right? Define oxidation in terms of electron transfer. So very simple. Loss of electrons. That's it. Once I see these words, 1 mark already. Easy, right? So when electrons are lost, is oxidation. When electrons are gained, is reduction. If you feel uncomfortable, oxidation means increase in oxidation state, right? Means electrons lost. You understand? Okay, so it depends on how you think, right? In oxidation state, easier to analyze because it's more normal. So electrons is opposite. Okay, 1 mark. Give yourself marks 10. Set the oxidation number of manganese. Hopefully you know this very fast, right? Remember this one, check periodic table +1. This part here is -8. So if you do algebra, +7. So +7, if you write 7 is wrong. If you write 7 plus is wrong. Understand? Must +7 like that. Okay, but for now, maybe I lenient a bit, but remember in the exam, sure wrong. Okay, -2, so this one here, +2, so +2. Understand? Any questions on calculating? Don't know, please stop me, okay? Because all these are real exam questions. Okay, which one to understand? The calculation, is it? Oh, no question, is it? No question, No, I mean, okay, good. Deduce which species has been oxidized in the reaction and state a change of oxidation number. So which species has been oxidized? We check. Which species has been oxidized? Which species has been oxidized? So difficult. I mean, complicated, not difficult. Sorry, wrong word. -1 to 0. So HCl has been oxidized. HCl, or if your school says Cl in HCl, please go and check which format they want. You understand? -1 in HCl to 0 in Cl2. You understand? These 5 marks must get because I think later on tough. These 5 marks is to help. So assuming these 5 marks you cannot get, later cannot get, then you mati die. You understand? So these 5 marks must get. Redox question must get. Okay? 10? Any questions? Start there. No questions, I'll move on. Count the marks 10 roughly. Don't worry so much. Okay? Okay, move on. Need me to re-explain any part type there. Okay, so final exam prelim so many. Okay, but don't worry. Okay. This is a more complicated electrolysis question, but I think can do if you are very clear with the concept, right? So first thing for electrolysis, before I look at the question, I will analyze the electrodes, right? So this is cathode, this is an anode, right? Because it's a negative here and this is positive. You understand? So cathode, anode, cathode, anode. First thing, label wrongly, everything wrong. You understand? All opposite. Now, W and X are made of platinum, right? So W is platinum, X is copper. Then this is carbon and carbon. I also label. But remember, our focus is always what? The anode, right? Don't be confused again. I say again, through practice, you can remember this, okay? You understand during class, but if you don't practice, you forget. So our focus is the anode. Whether is it reactive or not. The cathode, I don't really care, to be honest. I don't really care. You can see that. Don't really care. And the anode are all inert. Well, you know better. Okay. Okay, so I mean, before I look at the question, see, I do everything. Cu2 plus. Hopefully, you do all this practice. I mean, this habit. Correct. You understand? Write out all the possible ions present. Okay? Good. Predict if there will be any change in color intensity of the blue copper 2 sulfate in cell 1. Right? Relevant equation state symbol. Cell 1. So our focus is cell 1. whether the color will change or not, right? Okay, so I use this to teach, right? So first of all, I will sketch out, they say ionic equation. So I will hurry up do this. Remember, choose copper 2 plus equals, they say state symbol clearly. Correct? Okay, this equation, no choice, need to memorize, don't tell us. Okay, so these two equations should be some marks in the answer, because they say relevant ionic equation with state symbol. So I mean this might be 1 or 2 marks, I don't know, but you must write it out. Do you understand why I choose these two? Okay, can So once you write these two, then they say whether the color intensity will change. Of course will change. So blue solution or blue copper 2 sulfate solution fades, right? Because we start to fade. Why? As Cu2 plus ions are preferentially discharged at the cathode. Do you understand what I say? Cu2 plus is responsible for the blue color. Do you understand? Can. Selectively discharge also can. Preferentially discharge also can. Okay. Then, because 3 marks, maybe like that can already, but I want to say further, right? There is no replenishment of Cu2 plus at the anode, as the anode is inert platinum. Nice. The last line, I'm not sure whether it's in the mark scheme or not, but I think it's good to confirm it, because sometimes it is, sometimes it's not. Do you understand what I'm trying to say? If it's copper, it will what is it? What is it? So the green, what's green? Okay lah, still 3 marks lah, but can you add in still 3 marks because I take it as 1 mark, 2 mark, 3 mark. Okay, but I say going forward for your O level and for that one, maybe you just put in the red one as well. Okay, can you write it down also? You understand? So you must know that when there is a reactive anode, especially when it's copper, especially because blue copper link, then the equation will be Cu to Cu2 plus, there's replenishment. Then the blue remain blue, but if not, blue will fade. You understand? How do I include the second mark? Oh, the second mark is this one. Anode, cathode, 1 mark each. Understand? Means why need anode? Okay, because this part they are testing me whether there's replenishment. Understand what I say? Because if it's 2 mark, then you need. But if it's 3 mark, you got to either say my red one or you write the anode equation. You understand? Because remember in the notes, they either do a comparison when there's fading and there's no fading. So you cannot don't write the red and then don't write anode like that, only 2 mark. Right? You understand what I say? Because the idea of this is that they want to test you whether you do anything to the anode and whether the anode what happened or this. Okay, so no choice. If you write only the cathode and write only the green, there's only 2 marks. I cannot give you 3, right? Understand? Okay, so sometimes you need to some questions, you need to think what the question or the examiner is, they want you to know, then you can. You understand what I say now? It's like you read their mind first, but through practice now. Okay. Okay. Describe the color change of the universal integrator during electrolysis of concentrated potassium chloride. Okay, so concentrated potassium chloride, I select who? What's my equation? Explain, they never say lah. 1 mark, 2 mark, 1 mark, 2 mark. So I mean naturally I'll write lah. Okay, hold on. So cathode anode. So cathode H plus, right? 2H plus 2E minus gives you H2. And anode is what? Concentrated chloride, right? So it's 2Cl minus give you Cl2 plus 2E minus. Okay, so what happens is that the resulting solution is potassium hydroxide, which is a strong alkali, right? So color change, green to violet. Do you understand? Or purple. Okay. Universal indicator by default is green. You must start with green. Okay. Okay. So why cannot red? No. Universal indicator, no red because at the start it's not acidic one. Correct? How can it be red? So universal indicator by right is green, original color. Red is when it's acidic, but when the universal indicator is like if added here is neutral, right? This guy is a neutral guy. It's a salt. No. H plus and OH minus, they are equal. Understand? They're equal. If you say H plus acidic, die already. Every solution is acidic because every solution got H plus and OH minus. Are you trying to say that? You understand? There's no H, there's H plus, but there's also OH minus. So originally is neutral. And salt is neutral, right? This is a salt. You understand? So universal indicator is green at the start. Unless you throw into acid and green to red. If you throw into alkaline, green to violet. You understand? Unless it's weak, then it's the middle colors. Okay. Explain why green to violet. So 2 marks, right? 2 marks, right? Yeah, squeeze here, Ken. Since H plus ions are preferentially discharged at the cathode and Cl minus ions are preferentially discharged at the anode, the resulting solution is potassium hydroxide, which is a strong alkaline. Therefore, universal indicator changes from green to violet. 2 marks I got to be very naggy, no choice. If not, I don't know how to get. You understand? If it's 1 mark, I see before 1 mark, then they say that, oh, because the resulting solution is potassium hydroxide, which is not required, 1 mark, 10. But 2 marks, I will say those things on top. Okay, and the sad thing, I nag many times, is you practice your prelim paper yourself at home because cannot be every tuition. I try to have some, but cannot be every tuition, like waste of time also. So do yourself at home. But then from there, you look at the mark scheme. Oh, I miss out that, then I learn. It's like that one. You got to learn yourself. It's a training for your next phase, whether is it the JC or the IB, right? The A-level IB is the same. Training for next phase university is like it's a training. The process. Of course, in life, you don't need all this unless you're a chemist, but I never see any of my students become chemists. Have like some of them teacher, I think, but most of them not. They throw away, right? The process. This part must score. I think now D onwards may be a bit stressful. Explain why the volume of gas collected in each electrode of cell 2 is the same. So cell 2 happen. Okay, so I write here cell 2 2H plus 2E minus give you H2. 2Cl minus give you Cl2 plus 2E minus. Okay, so they are referring to these two. So why same? Right? So be careful. I tell you, okay, sidetrack a bit. Some students, they say, oh, why same? Because 1 is to 1. Okay, fair enough. You can say that. But if I give you this, hey, listen, important, always like that for exam. Some students say, 1 is to 1, same. Wrong. Because the moles of electron you never balance. If you want to compare mole ratio, make sure your moles of electron balance, same, equal. Do you understand? Okay, so if you want to compare with the red one, you better times 2 the top, like 4H plus this, not this Not this question, but this is a classic exam question. There 2:1. You understand? If you want to I power the mole ratio, make sure your moles of electron coefficient same. I say again. So for this example, you say that since the cathode and anode have the same number of moles of electron, the mole ratio of H2 and Cl2 is 1:1. Therefore, since both of them are gases, mole ratio equals to volume ratio. You understand? Therefore, volume same. Do you understand? This one, O level come up before. You better understand, then you can write up. But in order to compare gas, you can look at their mole ratio. Mole ratio is volume ratio, but only for gas. Any questions? How to find overall equation? Remember this overall equation, the blue one, the overall equation is what? 2H plus 2Cl minus give you H2 and Cl2. Are there? 1:1. Okay. So if you are comfortable, you say combining both equations, the overall equation is this. Then you can mole ratio already. Understand? But how to combine equation? Make sure your moles of electron the same. Okay. Okay. Last part. Volume of gas produced at electrode Y. This is the other number. I think the E is the tough one. Please listen. Okay. So electrode Y is what? Electrode Y is that? Oh, okay. So I need the equation. Oh, sorry. Electrode Y and X fly over that side, right? Wow. Okay. So electrode X is what? Okay. So electrode X is your Cu2 plus 2E minus give you Cu. Hey, pay attention, this one is difficult. Electrode Y is your anode chloride. Hey, pay attention. 20 grams of copper form. Okay, so listen to me. I take my calculator. Look here. We find the moles first. 0.3125 moles. The question is asking volume of gas. Means this. Hey, listen. 0.3125 moles. You find the moles of electron, you times 2. Do you understand? 0.625 moles. Right? Because ratio 1:2. Take electron as something. Right? Find the moles of copper. Then you find the moles of electron. The mole ratio is 1:2, correct? Then 1:2. Then because this entire thing is in the same circuit, the same battery on top, all connected, right, by the wire. So electron the same. They must know, as long as they are connected in the, if I fix the battery produces the electron, everybody will experience the same. You understand? Not because this is 2, even, okay, listen to me, listen. Even though this is, let's say, anyhow put 3, the moles of electrons still the same. Don't go and mole ratio. Mole ratio cannot be across equation. Mole ratio cannot be below and on top equation. You understand? It can be across only. Within the equation, you can mole ratio. I repeat again. When I put 3 there, can you see the in front of E, I put 3, not this example, but let's say I put 3. You don't divide by 2 times 3. You cannot mole ratio with different equation. This is important. They are in the same circuit. Important. It's like, you see, I tell you something. Why you cannot? Because it's the mole ratio only occur across within the equation, right? It's like I bake a cake, I mix the egg. 10 egg is to 1 sugar. Then I take that, I go into another equation with the yeast. It's a new equation. Of course, the mixture I mix, the moles is the same, right? But now I'm doing a new equation. Do you understand? A, okay, it's very important for exam. A plus 2B give you 5C. 2C plus 10B give you E. If I have 10 moles here, okay, I don't use 10. If I have 3.6 moles here, here also 3.6 moles, understand? Because I form the 3.6 moles and then I use it. Do you understand? This is an important concept also O-level ASA. You don't divide by 5. You cannot mole ratio below and on top. Why is it 0.625? I say why? Because I take this value, I times 2 lah. Because the ratio 1 is to 2, right? And because they are in the same circuit, they also experience the same moles. Do you understand? Every equation in the then why that equation is 0.625? Because they are in the same circuit. The moles of electron flow through everything, right? The moles will flow. So it's like 0.625 here, 0.625 electron, 0.625 electron, 0.625 electron, 0.625 rule finish. Cannot be, I connect to the battery, then one part, like got more or less, it's all same because it's the same circuit, like physics like that. So if I connect 10, all the electrons they flow out of the battery like that, means like that. So why? So how to answer you? Why the number of most electrons is the same for same? Yes, same battery, same circuit. Most of the electron is the same forever. There's no leakage. There's no addition. You understand? Important for O level, especially this thing also. Then 5C and 2C, yeah, same. Let's say same. Yeah, same. Okay, if they're all connected, that means step 1 is that, step 2 is that. You see the no. It can be a thing, no need electron. So whether electron or thing is the same, you understand? So C no need to be electron, can be like hydrogen. Okay, then hydrogen gas. Then I use hydrogen gas and react. It's the same. Because like I say I bake a cake. Step 1, I use the thing, I take that and go next stage. Understand? So in a nutshell, in summary, you cannot mole ratio with another equation. That is the thing you need to know. No mole ratio with another equation. I see this mistake 1 million times for students. And I can say, and then the student needs to make the same. Cannot lah, must know. Okay? Okay, continue. So if it's 0. Okay, so I take away the 3. So if it's 0.625, then the moles here is what? 0.625 moles. Divide by 2 because mole ratio 0.3125 moles of chlorine gas. Then like what Aaron asked, you times 24 dm cube to get the volume. 7.5 dm cube. If Cu is actually Cl with number of moles as 301, then the other equation of Cl, even though it's ratio of 2, it will be. Wait, what are you trying to say? So if Cu is actually Cl, if Cu is actually Cl with number of moles as 3125, then the other equation of Cl, even though it's ratio 2, yeah, correct. Maybe I don't understand your question. Can you say again? if Cu is actually Cl, what? If Cu is actually Cl, with number of moles, then the other equation of Cl. Okay, you got the right property. Is it Cl2 or Cl minus? A bit confused. What are you trying to say? Or you can write out type the equation there. If Cu is actually Cl. Okay, don't understand. You want to type again since I'll rephrase then. If Cu is actually Cl, Cl2 is it? Okay, maybe I give you an example, then you'll be clear. Everybody look here. 2H plus 2E minus give you H2. Okay? Together with 4, this is a common one. 4H minus give you 2 water plus O2 plus 4E. Okay, look here, everybody. Pay attention. Pay attention. Same circuit. Yes. Yes. Wait, same mole ratio. As long as it's the same circuit, even though it's an element, you will always have the same mole ratio. But provided the what? A bit confused. Okay, wait. Hopefully this will help you understand. Look here. Okay, look here, everybody. Let's say 0.8 moles. Okay? 1.6 moles. Everybody, do you understand? Same circuit, huh? Do you understand? 1.6 moles. Do you understand? This is what I'm teaching you. This and this the same because they are the same circuit. Do you understand? That's all. Yeah, answer a question if I tell you this way. They are the same circuit. Then what are you trying to say? Is it as long as it's in the same circuit, even though it's an element, it will always have the same mole ratio? Same mole ratio with what? No, mole ratio thing work for everything. So if I give you a real example, let me think of a real example. Like everything lah. No, not only electron. For example, let's say N2 plus, okay, anyhow give you H2 give you 2 NH3, right? Right, then 5 NH3 plus O2. Okay, anyhow give you, I don't know, doesn't make sense on maybe start. Let's see, okay, start. Okay, let's say don't care 10 and H4 blah 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 blah. You understand? Are you trying to say like that? Okay, anyhow. Are you trying to say this? Okay, everybody look here. O-level test. So please take note. 10 moles. 20 moles. 20 moles. Because same. This guy is used for the next. Right? Then times 2. 40 moles. Hey, you answer a question like that. Are you trying to say this? Yes, like that. Like O-level test, I tell you for so much. That's why I spent a lot of time. I think we cannot finish going through today, but never mind. Right, about this class. Today a bit stressful for me also. You understand? Okay. Can I move on? Think about it. Okay, think about it. Okay, so the answer is 7.5 dm cube. Hopefully you get this. Do you know how to do? This paper is tough. If let's say you never do well or a lot of mistake, after the lesson today, maybe rest 1-2 days or tomorrow or tonight or find a way you redo the same mistake, redo the thing again. Don't need to do so many question one. I see students get A1 or A for A level, they make sure everything they do, they know. You understand what I'm saying? That is the more important thing rather than you do. I see students do a lot, never do well. When you do for the sake of writing and make him feel good, that's not the point. You just do quality work. That means you finish doing, you wrong, you learn, you do second time, get correct, move on. Get wrong, do again, get wrong, do again. But you get so many wrong, you better ask me. You count the marks are over 10, or you can count later, okay? So stressful, very stressed, don't be stressed. Maybe this one next week, because but she got exam also right next week. Yes, yeah. Those. Okay, never mind, no choice. Okay, we just go through life first as much as possible. I know y'all got tests. Okay, come, look at this. So they use carbon monoxide with metal oxide, give you then got some so basically this is the reduction tube lah. You understand what I say now? Reduction tube means what? For example, ZNO, for example, ZNO plus CO reduce, Zn plus CO2, nice. Do you understand? ZNO plus CO give you Zn plus CO2, nice. This is what's happening. I want to reduce to get my metal, okay? My objective is to take the metal, put in my pocket. Okay, so how could Peter have ensured that the reaction reached completion? Because we don't know whether this guy fully react or this guy whether fully react. So 1 mark, how to do this? This is experimental technique. Ensure that the mass of solid left remains constant, understand? For a longer period of time. You understand what I'm trying to say? So after he do this, he measures 0.64 gram, but he must continue heating for another few minutes and check, is it 0.64 gram? Maybe 0.6 gram. It's not fully reacted. So the mass of solid must remain constant when it's finished. You understand? The mass of solid left is your metal lah. You must know this idea. Okay? The open end of reaction tube is lighted during the experiment. Why is it important? Okay, 2 marks. Normally 1 mark, but now 2 marks. Why must you have a flame? Okay, this is to prevent, because slowly what happens is that you have the metal and this experiment is very hot, so maybe the zinc is slipping here. To burn off oxygen present to prevent the metal from reacting with oxygen in the air. Do you understand what I'm trying to say? It's very funny. Okay, wait, my writing a bit bad. Hold on. From reacting with oxygen in the air. Okay, because it's very dumb. You get the metal, then got oxygen, then you form back metal oxide. Our idea is to convert metal oxide to metal. Then you form the metal, got oxygen, then you never burn it off, you react back. Okay, this is 1 mark. Normally, this is the only mark. But the second mark, because it's 2 marks, right, to prevent any CO from escaping, because got CO there, as it is poisonous, right? Burning. Okay, the flame. The flame allows any CO present to burn, to form CO2. You understand? CO is bad. No. Produce O2. No. Flame don't produce O2. Flame actually consume O2. Right? Burning need oxygen gas to produce CO2. Right? Do you understand? Okay, so burning is using up O2 to produce CO2. Involving the O2. Do you understand? As a reactant. Okay, so normally it's the first one, but this one they ask for 2. I got to think of is the CO problem, because if CO escape, then you learn in air pollution, it causes suffocation, right? So I wonder, so basically what's happening there, to burn off the CO lah, to form CO2. Nice. Okay, CO2 is not a poisonous gas, it's only greenhouse gas, but it's not a poisonous gas. You understand? Then to burn off the CO, right? The flame allows any CO present to burn, right? So I'm going to burn the CO to form CO2, right? So let's say got CO2 swimming here. Oh, some CO want to escape, but the burning here converts the CO to CO2, can? Plus O2 lah. Burn it away. Burn excess CO away. I cannot have CO escaping. It's bad. Okay, remember, you see, all this is not taught in the notes, not taught anywhere in the textbook. Teacher might say, might not say. It's really by doing it. Why is there O2 in the reaction? No, the burning requires O2, right? So there's O2 in the air or what you said. Burning means there's O2 present there. Right? This equation got no O2, but definitely the test tube, when you perform it, there's air is everywhere. You understand what I'm trying to say? So the burning there involving the O2, converting the CO, and also prevent zinc from reacting with O2. No lah, I mean, we hope that the metal doesn't react also. Then, of course, in every reaction, it's not 100% yield, understand? No choice. Right? So we are minimizing the oxide, the metal form to become the oxide back again. You understand? No choice, I know we try to minimize only, but of course in real life there's not perfect. Surely got some going to react already, then no choice already. Okay, so really, don't practice this part. I know everybody sure us how to do it. Okay, come. Maybe I can only do 2 more. Today very rushing. To rush off for my next class. Come. Do the next part. Identify the reddish brown solid form in the reaction with XO. Okay, so reddish brown metal, there's only one in your syllabus, right? Which is what? So the identity of the reddish brown solid form is your copper metal. Understand? Right, reddish brown solid. Most metals are gray, but this is copper metal, and the equation is what? XO, CuO plus CO give you Cu plus CO2. This is the equation. Okay, there's no other reddish brown metal. Most other metals gray. So they put gray here, I really cannot say. They cannot set gray. Gray got so many metals, most metals are gray, right? But the special one, pink solid, reddish brown solid, is copper metal. Okay, no choice. Only today I got extra class somewhere. So the rest, what I do is because all of you got exam, 2 of you got exam next week. Hold on, I going to